Where have you guys been? Have you seen it? Jude Law? No? Ed Harris? I know you haven't been studying for my class, so I thought you were watching movies. Guess not.
Absolutely nothing.
It was like AB.
Yes,
she got me.
All right. Okay, guys, you want to do some reactions?
Yes.
The moment you have been waiting for, yes?
Oh, those 20 things you need to remember? Is this when we use the flashcards?
Yes, this is when you use the flashcards.
Oh,
But you don't make the flashcards in class, okay? You make the flashcards in your house. Electrophile and nucleophile first. I am going to slowly work my way towards more and more details of this business, okay? I'm not going to give you a lot now. I'm going to slowly tell you about this. A negatively charged nucleophile is always better than a neutral nucleophile. Write it down. Negatively charged nucleophile is always better than a neutral nucleophile. What do you mean? Say that one more time.
Negatively charged nucleophile.
Negatively charged better. Is that like a riddle?
Negatively charged.
You have an attention deficit?
Is better than a neutral.
So, most of the time, this is what you should remember. Electrophiles are positively charged, while nucleophiles are negatively charged. Nucleophiles are the ones that attack electrophiles. This is a boy, and that's a girl. Okay? Not the other way around. Positive does not attack a negative. A negative, high electron density, attacks things that are delta positives or plus charges. Yes? Because electrons go from where there is a lot to where there is less electrons, okay? And nucleophiles then are like this. Is this a nucleophile? It has electrons. It is a nucleophile. Okay? Is this another nucleophile?
Yes.
Which one of those two is a better nucleophile?
One with a negative.
The negatively charged nucleophile is a better nucleophile. That will be a test question for you. I'm going to give you a whole bunch of things and ask you which one is a better nucleophile. Just like I asked you which one is a stronger acid from the list that I gave you, and a lot of you chose, I don't even know what you chose. None of you chose a carboxylic acid when I told you that the pKa of that was from 3 to 5. Stronger than that is a strong acid. Okay? And electrophiles are things that are, for example, this here. What type of charge will this have? This will be, this is delta negative, while this is delta positive. And if you have a carbon with a halogen on it, I should write it like this, yes? If we have a carbon with a hydrogen on it, this is, with a halogen on it, this is delta negative, while this is delta positive. So if any of these nucleophiles were to attack these things, where would they attack it at?
Positive.
They would attack it at the positive center. It would attack here, or it would attack there. Yes or no? How about this? This here. Is that a nucleophile or is that an electrophile?
Nucleophile.
That's a problem, yes?
It's a nucleophile.
It could act as both, okay? It depends, but we know that this pi bond here has electrons, okay? because it has electrons, it can act as a nucleophile. But things can attack that double bond too. Okay, because by resonance structure, how is this going to look? If I put the 2 electrons on one thing, how does that look? This looks like positive, while that looks like negative. So it's like a double bond, has electrons, but it also has a positive side. Okay? Yes or no?
Yes.
We can call this reaction hydrohalogenation. Okay? Or we can call this reaction addition of HX, where X is equal to Cl and Br. So additions of HCl and HBr to alkenes, or to double bonds. Okay? So we are going to have a double bond. First, I am going to give you the generic of this reaction. The generic is, we have a double bond, and we are going to add to this HCl. So you have this stuff in a flask, and you add HCl to it. And what is going to happen is addition. One side of this will go to one carbon, and the other side of that will go to the other carbon. Okay?
Yep.
You are going to lose the double bond. The double bond is going to go away, and what you are going to form are single bonds. You want this color coded, don't you? You want a color code?
Yes.
Because out of all these pens, I don't have a use for them. Which color do you like? Purple?
Red.
Red.
You like it red?
Yep.
I like to put purple.
Cause it's hot
Right.
tonight. You on fire.
Okay, I'll give you red in a little bit, okay? That's a girl color.
I have a better purple.
On one side, it will be the H, and the other side, it would be the Cl. Yes?
Yes.
Actually, we should do it like this. Okay? That electron pair is from where? From there is that electron pair. And that electron pair is that electron pair. Okay?
Why did it go on to the Cl?
I will show you the mechanism later, my friends. Yes?
Yes.
So from an alkene, when you add that, this reaction is called the hydrohalogenation. You are going to get something called an alkyl halide. Alkyl halide or haloalkane or haloalkane. You guys remember this functional group? Alkyl halide?
Yeah.
Yes? Yes or no?
Yes.
This is how you make the first flashcard. You want me to show you how to make the flashcards?
Yeah.
This is how. You are going to write in the front of the flashcard, you are going to write an alkene. You're going to write this, or you're going to write this, and you're going to put HCl or HBr, and you are going to leave this blank. Yes? Whatever alkene, that and that blank. And you're going to put the answer to this in the back. Okay? You are not going to overwhelm the flashcard, so you can remember little bits at a time. So this goes in the front, and that goes in the back. Or you can just write alkene plus HCl give you
Alkyl halide.
alkyl halide goes in the back. So how many flashcards is that so far? 2 flashcards. One in, what do you mean houses? So one the structure and the other one the works. Or you can put this and this, I mean this gives you that, and omit this, and this is what goes in the back. So whatever you are missing, you're gonna put like a question mark. So if you are missing this, you're gonna put a question mark, so you know that that is what you're asking for. If you leave this blank in the front of the flashcard, you're gonna put that in its place. Yes or no? Hello?
Yes.
You guys tired or something?
So, there's 3 flashcards per item.
No, we're not done with them flashcards yet. So you put this and that, omit this. You put this and that, omit that. You can put this and that and omit that. This is the question mark you put. Okay? Yes? That way you remember once in a while the reactants, once in a while the products, and once in a while what is needed to go from one to the other. I am going to ask you all 3 types on the test. Okay? And then you can put little details like the ones we're going to do next. So let's do a real example, okay? Give me the product of that.
Professor,
You're waiting.
how do you know which carbon gets the hydrogen if you attack the
They're
hydrogen?
both the same. Yes.
They're both the same? Okay.
I mean, I see they're both the same.
Okay.
We're not there yet, okay?
Okay.
Don't mess it up for me. The purpose is to shock you when you try, when you think you know something and you don't. You guys did it all right?
Yes.
What are you guys staring at? It's not polite. So, what are you going to do? That's that, yes?
Yes.
That's that. That has a CH3, an H, and one H is going to go to one side and the Cl is going to go to the other, yes or no?
Yes.
So I'm going to put one H on one side. Does it matter if it's here or here?
No.
From what I see, it's kind of symmetrical, so you put an H on one side and the Cl on the other side, okay? And what you have is H and CH3. I did not place it in any particular order, okay? I just put it wherever.
It doesn't matter where you
At
put
this
it?
point.
Okay.
At this point, it doesn't matter to you.
Does one bond replace that double bond?
What happened?
Does one bond replace the double bond?
Bromine,
One bond replace the double bond?
one bond replaces a double bond? No, 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 not that, not one bond, 2 bonds, yes? 1 and 2. Yes? But one of the electrons, like the electron pair, is from the double bond. Okay. Okay, draw what you think the product should be. Don't ask anything. No, it's an alkene with HCl or HBr. It does work differently, but it's the same type of reaction. It is different from what we have done. Okay? So, here's what I'm going to do. Yes? Here's where the double bond used to be at. Yes? Down here. To one side I'm going to add H, and to the other side I'm going to add Br.
Yeah.
So I can add the H to this side, yes? And the Br to this side. Yes or no?
No.
No, no. I'm not saying yes or no. I'm saying we added this, yes?
Yeah.
The H to one side and the other one to the other side. Or the H could go to this side, yes? And the Br to this side.
Yes.
Yes or no? That is another possibility.
Yeah.
It just happens that this, where the hydrogen went to this carbon, does not happen.
That's right.
So you are going to write that this addition is regioselective. Right? Regioselective. So the addition of HCl or HBr to alkenes is regioselective. That means that it selects what? The region. That's right.
That's right.
It selects the region where it's going to attack. It doesn't like it like this. Okay?
Wait. You just patient. Did it virtual.
I'm going to show you, okay? Regio, yeah, whatever. So the reason why this doesn't happen, Sophia, you're missing it. The reason why this doesn't happen is based on the mechanism. Yes? It is based on the mechanism, which we are going to do next, okay? This is what happens most of the time. This makes no sense, but the region where it adds is called Markovnikov addition. Markovnikov.
I'm guessing he was Russian.
It was Russian? Yeah, that's all they did, chemistry and vodka.
That's right.
You're a tequila person? All you do is eat tacos and drink tequila. All right. So, Markovnikov addition says that the hydrogen will add to the carbon.
No, I think I missed it.
Yeah, I got it. Start.
With more hydrogens on it. We have to start over. That's Markovnikov addition. The hydrogen will add to the carbon with most hydrogens on it. How many hydrogens does this carbon have?
2.
2 hydrogens.
Yeah.
Yes. 1 and 2. How many hydrogens does this have?
1.
1. So the hydrogen, the new hydrogen, will go to what side?
To the right side.
To this side. Okay. And the reason for that is based on
Markovnikov.
the Markovnikov addition, but it is because of the mechanism. It is regioselective. Now let's do the mechanism. A famous mechanism. Oh no, what? What you guys say, oh no? I am going to ask you 3 or 4 mechanisms on the test, okay? And you have to do the mechanisms with love. Do you understand what that means? If you are careless, where you draw this arrow, we were supposed to talk about the test, yes? But when is the test? What test? We're talking about the previous test.
Previous test.
You want to take another test already?
In 2 minutes.
There was a question on that test.
With the arrow rule?
Yeah.
Yeah.
Which some of you chose this wrong, yes? Was it like this? That it went like that,
Yeah, yeah.
yes? And because you were doing things with love, you thought it shouldn't look like this, yes?
Yeah.
So I give you credit for that question, okay? So you're right. Some of you said, look, I got this question wrong because
Wait, that's what I was, but I like particularly asked if it was a software issue. That was my answer.
I what?
I particularly asked if it was a software issue.
Software?
Yeah, because I saw that and you said, no, it's a mistake.
Yeah, you
So
told
I
me.
particularly didn't pick that, although I thought it was.
No, you can't pick that. That was not the answer.
I know, but if you picked that one, then you got credit for it, right?
No.
Everybody got credit for it?
You picked the answer. You picked that answer and you're wrong.
Right. But you would
You
get
just
credit.
said you.
Guys, did I say that it was right or that it was wrong?
It was wrong. It was
I
wrong,
said-
but you gave credit.
I never said that it was right or it was wrong.
No.
I mean, you gotta use your ears a little.
Yeah, you said you were.
You guys got ear what?
You said we were being generous.
La Visa, did you just get to my club? What I'm saying is, since this was not drawn correctly, even though it wasn't the answer on the test, that was not the answer, because that was correct. That is okay to do, but it didn't look the way I told you that these things should look. This should have looked like this, yes? Should have looked like that without landing on top of the electron, right? Some of you picked that wrong. So I'm going to give everybody credit for that question, whether you got it right or wrong.
Okay.
Yes?
Was
Was there anything else?
For the iron.
Oh, the acid, the acid,
Acid.
What acid?
We did
The iodine.
the ones, yeah, they're on the same group.
I mean, I got that right. I know a lot of people want to, they want to know why.
Okay, whatever, let's continue, okay? You remind me next class. I mean, this is...
One per class.
Huh?
One per class?
Okay, we'll talk about it later. Okay? Is that it? Okay, let's do mechanism, guys. Shut it.
Professor, someone has a question here.
Number 25.
Yeah, at the end of class, okay?
Okay.
I wanted to talk about it at the beginning of class, but you guys were sleeping. Alright. Okay, so this is what happens. Look. Here's the double bond, yes?
Mechanism.
And here is HCl. Okay? That double bond. By the way, is there a difference between this line being down there and on top of it?
No.
No, please. It's a double bond, is a double bond. So from here, which side is positive, which side is negative? Hydrogen is positive, this is partial negative. So what happens is, since the double bond is an electron pair, it is going to attack the positive side from there. I am going to draw this from the middle of the bond, and those two electrons in that pi bond. Do you know how a pi bond looks like? Because I asked you to give that to me on the test.
Yes.
It looks like this, yes? With the two electrons going around. They are on top. So what happens is that this electron pair attacks that, and can this hydrogen now make two bonds?
Nope.
No.
No, it cannot. So if it's going to make a bond here, that has to break, yes or no?
Yep.
And you are going to say that this breaks like that.
Oh.
You are not going to stick it inside of the electron pairs.
But if you do it on top, does it matter? Like if you do the arrow on top?
You mean if you do it like this? Like that?
Yeah.
No, that is not okay.
Oh,
Okay. Good question.
my bad.
Like I said, that shows no love, yes? That's why I'm giving you credit for the other one, because the other one did that like that. So you are going to say it goes to the outside, okay? It took the chlorine and the hydrogen bond broke, and who took the electrons?
Chlorine.
The chlorine took the electrons.
Yeah.
And of course, now this hydrogen is making a bond to one of these two carbons, either this one or this one. According to Markovnikov addition or Markovnikov rule,
The outside.
it's going to get attached to the one that has more hydrogen. So it is going to look like this. Here's what I used to have, and now the hydrogen is here. This also had hydrogens from before, yes or no?
Yes.
I did not put the hydrogens it had from before. Do you want me to put them?
Yeah.
Yeah, let's put them. Here's a hydrogen, here's another hydrogen, and here's another hydrogen. Okay? Is that better? So, here's a hydrogen, and here is the other hydrogen.
Right.
Everyone understands that? Yes or no?
Yes.
So now, this carbon here has 3 hydrogens, one from the HCl, and the other 2 that it had. Any formal charge on this thing? Oh, there's a
Negative.
hydrogen here.
Positive on the carbon,
On the carbon.
and negative on the
Of
chlorine.
course, this was neutral. I
Yeah.
used the 2 electrons from here to make a bond to this carbon.
Uh-huh.
Now this carbon that had the double bond now
Positive.
has 1, 2, and 3. 1, 2, and 3 bonds. So that has a formal charge of
Positive.
Everybody has to know that that is a formal charge of positive.
Positive carbon cation.
And this carbocation, yes, that's what we call it, carbo. This carbocation has what type of structure?
Trigonometric planar.
Trigonoplanar.
Planar, yeah.
What hybridization?
SP2.
SP2.
SP2. So, this is trigonoplanar. Looks like this, yes? Or I can say that is how it looks. A trigonoplanar is flat and it has empty orbitals. These orbitals were the ones that were doing what? Making the pi bond.
Right.
Which you guys, some of you missed this on the test. I asked you for a double bond, you give me a triple bond. Shame on you. So, now, this has a top and a bottom, yes? Yes or no?
Yes.
So something, it's a plus on the bottom too. I don't want to write another plus, because then it looks like I wrote 2 pluses,
Yeah,
yes?
yeah,
The plus is that it's missing electrons. Something can attack it down here, or something can attack it up here.
yeah.
Yes or no?
Yes.
If something attacks it from the bottom, you might get stereochemistry, meaning you might get R, and if something attacks it from the other side, you might get S. So, you might get R, you might get S, you get both. So whenever you have a carbocation, you think about that you are going to get R and S. Okay?
Professor, I don't understand that. Professor, we don't need to draw the
Yeah, we're not done. Still talking. What don't you understand?
I'll come see you later.
No, no, just tell me what don't you understand. Half of the class probably doesn't understand.
I don't understand, like, first of all, what about the CL right now?
I'm not done.
Oh, okay.
I just created this carbocation, and I am talking about what the carbocation is, yes?
Yes.
The carbocation is flat, and it has a top, and it has a bottom. Things can attack from the top and from the bottom. They can give you R, and they can give you S. There is no reason why, if it's flat, that you're going to get more of one than of the other. So if it is through whatever you're doing, if it is through the formation of a carbocation, most of the time you're going to get a racemic mixture. You guys remember that?
50-50.
50-50. Yeah.
If it's attacked from the bottom in this particular example, you get R.
No, no, no. No R, no S. There's nothing, there's no groups there. So, now, what else happened to this here? The electrons went to the CL. So now, it looks like that. Yes? Maybe I should. Okay, now the CL has what type of charge?
Negative.
Negative. The negative charge is the charge. It's not an electron pair.
Right.
Yes or no?
Yes.
The negative charge is the charge. Please, don't disrespect by going like this from the negative charge. It's not from the negative charge.
Yeah.
It is from the electrons. Specifically from where? In the middle of the electron.
Yeah.
That's from where? You can choose whichever one you want. I don't care.
As long as the arrow looks good, right?
So, now this is negative, and guess who's here?
Positive.
The girl waits.
The electrophic.
Okay? The girl is waiting all by herself. So,
And the pretty boy.
what is going to happen is, no, he's not so pretty. He's hungry though.
Savage.
She's gonna go for that one. Okay. So, this boy here is going to go like this
Ooh.
and attack that there. That's right. Okay? And when it attacks that, what does it form? It forms this thing that I had from before, with a hydrogen here, and the other hydrogen. Well, that electron was from this, and the CL. Now the reason why this plus is the one that was formed, the reason why my Kornikov addition says that the hydrogen goes here is because this carbocation is a secondary carbocation. Did we talk before about primary, secondary, and tertiary?
Yes.
Yes. This carbon here has how many carbons on it? 1 and 2. That's secondary carbocation. Maybe I did mention to you what is more stable, yes? So let's do it right now. This is a primary carbocation. No, let's say this is, let's do it like this. Methyl carbocation. Not very stable, yes? And then you have this carbocation, which is called primary. And then you have this type of carbocation, which is secondary. And then we have this type of carbocation, which is tertiary. There is no quaternary carbocation. So the most stable carbocation is tertiary carbocation. Now there are other carbocations like benzylic or allylic carbocations, which I am not talking about. But these carbocations like this here are primary, yes? No, this is vinylic. No, it's not. This carbocation here is allylic. It is on the carbon. Let's do it like this, yes? It is on the carbon adjacent to a double bond. This carbocation is very stable. Why is it stable? It is stable because it's resonance stabilized. Because I can go like this, and this positive will then go here. Because it's resonance stabilized, it's stable. And benzylic is one like this. That's called benzylic. This is called the allylic. Okay? How's that, guys? That was called the mechanism. Most of this class, we are going to do mechanisms. All you should look forward is mechanism, mechanisms, mechanisms. Because a mechanism is the explanation of why things work the way they work. So, why is Markovnikov addition? Why does the H, I'm not asking you what it is, I'm asking you why. The H goes to the carbon with more hydrogens, why? Because it goes through the formation of a carbocation intermediate.
Oh, wow.
That's the, you guys, carbocation, you didn't see it? Maybe we should do another one, yes? Goes through the formation of a carbocation intermediate. Every time you have a carbocation intermediate, you need to have, what type of carbocations are the most stable? Tertiary, secondary, primary. If the hydrogen would have added to this side, there was a hydrogen already there, yes, on the double bond. If it would have added to this side, then the carbocation that would have formed was this carbocation, which is primary. This carbocation does not form because it was primary. There is a choice. The carbocation that will form was this. Because this carbocation was secondary. This is the one that formed, not that one. Markovnikov addition is a result of what? Carbocation stability, yes? It is a carbocation intermediate, but it is because of carbocation stability. Give me the product for that. Now give me the product. I don't want, actually, you know what? Give me the product and the mechanism. Can you do the mechanism? It's too fast.
You can try.
What do you mean?
Too soon for us to do it? Come on.
Yeah, too soon. Yeah, too fast in time. Yes.